This is the single most awesome moment in the history of technology.
Today I'm sitting down with Jan Liphardt, the founder and CEO of OpenMind. Jan is also an associate professor of bioengineering over at Stanford University.
There are approximately 1,000 different models that are relevant to robotics, and all those models do very different things.
The OpenMind team is building an open source AI native operating system for robot intelligence.
What we do at OpenMind is we are building a open source software stack for human-facing robots. And the really simple, compact version of what we're trying to do is Android for humanoids.
The company recently announced they raised $20 million and are getting ready to announce the first app store for the robotic space. I hope you enjoy the conversation. Remember to go direct. Hey, my friends, Jordan here. Just a few words before we hop into today's episode. First and foremost, a sincere thank you and appreciation for all of our early listeners, readers, and supporters at Going Direct. It's really what keeps me going to do this each and every week because there's clearly a community of folks out there looking to build a Going Direct economy, which gets me super excited. Secondly, if you haven't subscribed, please do so. Our main channel and community is forming over on Substack. The link is in the show notes below. And we'll also be putting out our weekly conversations at YouTube, Spotify, and Apple Podcasts. I hope you all have a great day. And remember to go direct. Okay, we are live. I'm coming to you from Detroit, Michigan, -20 today. So I'm in a remote recording studio instead of my traditional studio, but nice and cold here. Jan, where are you joining in from?
San Francisco, California.
Okay, much warmer out there, I assume.
Well, we have a gray day here, and but of course we can't compete with -17. As a fun fact, I grew up right outside of Detroit, so I still remember the winters there and making igloos and things like that. My dad was a car engineer, and my earliest memories ever are sitting on top of a car engine in Detroit with the hood up as like a 2-year-old.
Nice. Where did you grow up? What part of Detroit?
Bloomfield Hills.
Oh, that's funny. I grew up in West Bloomfield.
Oh my God. Wait, which elementary school did you go to? Well, wait, we can do this later. Let's focus on robotics and technology.
Oh, I love that. I didn't know you were from Michigan. That's great. That's a fun part about meeting folks on the pod. So, all right, so here we go. So, obviously everyone that's listening or watching, I keep yapping over and over again because it is the whole idea behind Going Direct and building the Going Direct economy is to decentralize the real economy. How do we reconnect consumption with production? How do we move more towards more decentralized systems to get back connected to the products we buy and people that make them? And, we have kind of three main pillars of the Going Direct economy. And at the heart of it is decentralized production. Because I think robotics, automation, and obviously AI all converging is the only way we're going to be able to get there in the West. And in order to do that, robots need to be intelligent. And this is why I was excited to speak with Jan about what they're building at OpenMind, and more specifically, your backgrounds, which we'll get into, because it kind of spans the intersection of biology, robotics, decentralized systems. So I think it's like a highly relevant conversation. So.
Thank you. Yeah, sounds super interesting.
All right, so let's start here. We've had many conversations on the pod where, it's very clear there's a consensus view that, obviously everyone agrees robots are coming in a very profound way, but people have many different perspectives and approaches of how they'll scale and actually how they'll get deployed. And so I just wanted to get your perspective. I know there's a lot of bottlenecks here and everything's kind of being built at once in a way. But is there kind of one most critical bottleneck holding kind of the next gen robotics or generalized robotics back today that you're like, this is just the most critical piece that you feel very strongly about?
Well, there's a lot to unpack there. When you're having a conversation about robotics and automation and manufacturing, one thing that a lot of people struggle with is the diversity of robot form factors, capabilities, and use cases. You can sit at a table with 10 roboticists, and every single one of them will be working on something totally different that for their application, their use case, their form factor is critical. And so in general, what we find is that when you're trying to answer questions about, what's the bottleneck for robotics, it's all about being specific. For example, if you're building a robot to make cars, you have a totally different set of things you're optimizing for compared to a robot for household use to chop onions, or a robot that works outside to whatever outside use cases are. This is like an inspection use case or something like that. So when people talk about robotics, the first thing to point out is that there are hundreds of use cases and applications and form factors, and the software stack must represent that diversity of use cases and skills. And when it comes to, from my perspective, the big unlock was the recognition that large language models are not just good at generating images or generating text and computer code. Large language models can also be slightly repurposed to control robot hardware. So imagine taking ChatGPT and attaching arms, legs, and sensors. And all of a sudden, ChatGPT stands up in front of you and says, "Hey, Jan," and you have a conversation with ChatGPT, which is now able to physically explore the world with its own arms, legs, and sensors. That kind of technology is most relevant for humanoids and other robots that interact with humans. For example, for education, for example, for health companionship, for example, for safety, because that type of robot architecture tends to be really smart, but slow. So that's not the kind of architecture you want to be using for like drone guidance or something like that, or ballerina dancing humanoids. In terms of the technology overall, I have two kids. And as a parent, I have a very basic set of priorities. I want the world that my kids live in to be awesome. And I want it to be safe, and I want it to be flourishing, and I want it to be open. And when I look at a lot of technologies being built right now, I think most parents have to ask themselves really basic questions like, what shall my kid major in college? Or what kind of skills do I want to make sure my kids learn, and so forth. And in that context, from this like parent perspective, it's really important to me that as machines wake up and as machines get smart, I want the computer code that is controlling those machines to be open. I want kids everywhere to be able to look inside the brain of a robot, kind of understand what's going on, and also be able to participate in that world. I want them to be able to improve the software, add new features, do fun and awesome and creative things with robotics. I do not want a world where there's a knock on your door and you open the door and a big humanoid that's 2 meters tall says, "Hey, I'm your new humanoid." And I don't want that kind of technology and that kind of system to be like magic. I don't want it to be secret. I don't want it to be closed. I want this kind of technology to be something where developers everywhere, and kids and teachers and professors and whatever, to be able to interact with it and contribute and engage with the technology. So that's kind of why I started OpenMind. And what we do at OpenMind is we are building a open source software stack for human-facing robots. And the really simple, compact version of what we're trying to do is Android for humanoids. So that's this notion of there's this amazing technology. It has speakers and microphones and screens and batteries, and it's connected to the web and all this other stuff. And wouldn't it be nice if all the different humanoid robots that we see being developed around us, if there was a good open source software stack for them that normal developers everywhere can engage with and participate in?
Great. It's interesting. You hit like a really important point. I talk about this a lot in the writing and in our conversations. And when we talk about, to your point around kind of when I mentioned about decentralized systems and creating this more decentralized economy, I think your kind of perspective on this kind of open versus closed source and the role of this technology, what I often see happen is not only do you have to have the right, like you said, approach. I think that approach aligns with our kind of values around the kind of the open source approach, but it also then needs to be hooked into what I see a lot of the technology companies, how the companies capitalize. What is their incentive structure, right? At the end of the day, what is the incentive structure, and that is around typically the business model. And I think that's where I just see a lot of compromise there. So I think if we're ever going to get there, we have to think about incentive structures and making sure, like in your case, your incentive structure is getting as many developers and as many people on the platform. And by choosing open source, it creates a very different, I think, I don't know, just kind of the orientation and incentive structures just a little bit is different. So I appreciate that. Let's dig into kind of, as you kind of just gave a quick background on OpenMind. I want to dig into that a little bit further. So, your, I believe it's called OM1, correct? Your first kind of first version of your AI native operating system for robots. So, in its simplest way, a cognitive layer for robots. I think the term AI native is now kind of turning into a buzzword a little bit. So, can you kind of just unpack a little bit what you mean in the context of what you're building as AI native?
Sure. So every single person listening to this podcast, I'm sure, has used ROS2 to write code for a vacuum cleaner. And of course, we all struggled with Cyclone DDS, and maybe we struggled with Zeno, and then we struggled with drivers, and then we struggled with all the different messages, and then we wrote Python code to get the vacuum cleaner to navigate our living room in a zigzag pattern, and then we added code to do collision avoidance, and then we tried to somehow get it to work. This is sort of my experience. And after many years of working with that kind of software, I think quickly became clear that for certain robot applications, it's really good. But what I was missing is the ability to make the machine a lot smarter. And so I remember, I'm sure this is true of all of us, sitting at our computer and you put in prompts into a large language model, and really interesting things come back. And so I just started giving prompts to large language models that were descriptions of particular scenarios. And imagine the following scenario. You're a humanoid robot. Your goal is to help children understand math. You are in a room. There's two children in front of you. One of them is called Ben. He's in middle school. What is the optimal next action? And I was just curious to see what the large language models would do. And what I got back from the models, and this was now like 2.5 years ago, was shocking to me. Shockingly good.
Okay.
I got recommendations about what to say, recommendations about how to behave, recommendations about how to move. Things like, look at the child in front of you, take a picture of the homework in front of them, use tools to, and all of this stuff came spewing out of large language models that were designed to create digital outputs. But so I was looking at these outputs in front of me and said, wouldn't it be really nice if it were really simple to connect outputs from large language models to physical robot hardware? And that was the starting point. So we did not start with, how do I build a robotic vacuum cleaner that deterministically executes a zigzag pattern in a 10 by 10 foot living room? We started with, There's a fundamentally new technology that is able to do data fusion across many sensors. It's able to use tools, and it's able to win the math Olympics, and it's able to generate computer code, and it's able to generate lists of actions that, if and only if there were a suitable glue or adapter technology that allowed me to graft that kind of capability onto physical hardware. And that's what OM1 is. So it's AI native because we started with large language models and then built a system to make it super easy to push data from dozens of sensors into those large language models and then take the outputs and convert that into action, speech, emotion, movement, jump, sit, charge, explore, that the hardware can then execute. So that's why we call this AI native. And we've been using the term since before it was for VCs.
Great. And just to explain folks that might not be as deep in the robotics space. So obviously many folks hear of the most common term, robotic foundational models or world models, VLAs, vision language action
Yeah.
models by prompting a robot through text to do an action.
Yeah.
Talk just a little bit about how you, because what you're doing is different as this kind of connective tissue, how you interact with maybe these different robot foundational models and LLM, these text-based LLMs as well.
So right now, there are approximately 1,000 different models that are relevant to robotics. And all those models do very different things. For example, for a humanoid robot to understand voice, you need a voice to text model, for example. If you want a robot to understand data coming from a LiDAR, you need a LiDAR to text model, for example. If you want a robot to understand spatial environments, you need yet another type of model. If you want a robot to be able to win the math Olympics, you should pragmatically just reuse a large language model. If you want a robot to know what it means to be a cat, a dog, or a human, why not repurpose a large language model? So what we're seeing is that given how many models there are, where they're being developed, and what the use cases are, that you can do amazing things quickly and at low cost, very pragmatically, by grafting together existing models. And that is this philosophy of many small models. The multi-agent world, and of course, people love connecting lots of different models to build agents or like multi-agent systems. And it's exactly the same kind of thinking, just mapped onto robotics. When you use many small models, it's very easy to upgrade the stack. It's easy to debug. You don't like the performance of the voice recognition, put in a new voice model. You don't like the performance of the math Olympics winning model, put in a different large language model. And then there's another philosophy. The other philosophy tends to prefer a small number of models or even one model. And for many situations, for some use cases, that's exactly what you want to do. A great example is Tesla's self-driving. A car is a robot. It's a wheeled robot. And it's a wheeled robot with very specific expectations. What the wheeled robot is trying to do is take typically vision data, and it's converting that into 4 outputs: turn left, turn right, accelerate, or brake. And for that, if you collect 10 years worth of driving data, then then it turns out to be very powerful to build one amazing large model that is then able to control the car. And none of these are right or wrong. It depends on precisely what you're trying to do with your robot. Are you building a drone? Are you building an underwater robot? Can you do some compute in the cloud? Can you do some compute locally? Are you building a health companion that needs to be able to speak 65 different languages? Are you building a robot to chop onions? So once you've decided specifically what you want your robot to do, then you have enough information to make good decisions on the architecture of the software stack. And for everything we focus on as a company, our robots right now do not have hands. So we are focusing exclusively on tasks like education, health companionship, security, receptionists, greeting people at CES, and helping conference attendees find the right booth. None of those type of tasks involve chopping onions or wet wiping floors, for example. And for those kind of use cases, this multi-agent architecture, multi-model architecture turns out to be pretty awesome. But for other use cases like chopping onions, it's probably the wrong thing to do, because there you need exquisite, fast, low latency connection of the observation, the onion in front of you, with coordinated physical actions. And the only way to solve those problems is through what you might call a world model or foundation model or end-to-end AI or whatever term you prefer.
In your mind, as kind of you guys, is it if you as you move forward, as the field moves forward, do you see yourself though then getting into different use cases where there are specific tasks and that where the dexterity is better and everything is maybe a little bit more just more advanced, I guess.
Sure. Well, dexterity is getting dexterity, of course, has a physical component and a software component.
Mm-hmm.
The hands you were able to buy last year for humanoids, most of them were pretty bad. For example, a typical experience was you'd pay $5,000 for 5-fingered hands, and 100 hours later, one of the fingers would break. And that can be incredibly awkward because if the middle finger breaks extended, people just really, they see your humanoid and you can't do anything about it because the finger's broken and everyone's giggling. And of course, so last year, I think it was way too premature to think about deploying humanoids with hands into a normal like family or hospital setting. But this year at CES, for the first time, I saw a good robotic hand for $1,200, which is a really good deal as far as robotic hands go. And they also quoted mean time between failure values of 100,000 actuations and things like that. So the hardware is finally getting to the point where manufacturers are now quoting reliability numbers. That's pretty awesome. And a lot of people underestimate the amount of brain power we spend on our eyes and hands. To first approximation, a large chunk of what our brains are doing is dealing with visual information and coordinating that with our hands for movement and dexterity. And of course, there's an amazing opportunity for humanoids that are mechanically and physically have that degree of dexterity for things like assembly and many, many other tasks. But for us as a company, we don't think that is the right thing to focus on this year. The way we're approaching our go-to-market is let's start waking up humanoids. Let's start them being able to navigate spaces, go to places, talk, listen, remember, recognize you, help you. And then next year, maybe add a simple gripper. Then the robot can help you by picking up, a grocery bag. And maybe the year after that, add a 3-fingered hand and so forth. So we think of this like very pragmatically and incrementally. instead of we're going to hide in a lab for 10 years and
Sure.
come up with the perfect 85 fingered contraption. So it's really important for us that we get robots in front of normal people, including in Detroit,
Hmm.
and just get input on what normal people want.
Yeah.
What are they scared of? What do they want help with? What are they looking for? And so that's why we're really emphasizing getting the technology in front of normal people today, even if the hands are just like little stubby pieces of plastic. Who cares? That's fine this year. And then, of course, we'll keep adding new capability as the hardware and software gets better.
Got it. And so obviously kind of what your guys' approach is a hardware agnostic approach
Yep.
where, so can you just talk a little bit about, because many of the folks that are building humanoids or other robotic systems, they're not open source. And so is it kind of a one by one piece where like, what is the process of bringing on board, Ubitech or any other manufacturer that's making a robot to like work together?
Yeah. That's a fascinating question. And there's no simple answers here. Typically, the way this works is a company calls us and say, "Hey, we're looking for good software for our humanoids," and we say, "Sure, let's talk." And then there's a multi-week back and forth where our engineers ask their engineers for which sensors are you using and how is your depth camera connected and what does your microphone look like and which version of Jetson are you running and what does your battery subsystem look like and what are the Cyclone DDS messages you're using 8 layers down. So there's a multi-week process of just understanding the hardware. And then typically, and I know this may sound surprising to a lot of people, typically at that point, we can get our software to run on new hardware within something like a week.
Okay.
And that is because when you dig into most robots, if you dig deep enough down, they're kind of all the same. Like to first approximation, most robots, they're going to have some rock chip. The rock chip is going to deal with battery, the IMU, and some basic motion policies. And that will allow the robot to stand up, sit down, deal with thermal and battery. And that right there is about 75% of humanoids right now. There's some version of a rock chip running, and that's like the generic architecture there. And then there's going to be a second computer, and that's going to be typically some NVIDIA. Maybe it's a Nano, maybe it's a Thor, maybe it's an Orin. So those are all going to be running Jetpack one way or the other. And then what a lot of companies have done is they've added their own outside, like their own SDK, their own API, their quote unquote proprietary special
Sure.
super awesomeness system. But generally, that's a very thin layer on top of what is very frequently all the same stuff. There's going to be middleware running, and like Cyclone DDS is probably a frequent choice. There's going to be a rock chip. And when you've seen 25 different humanoids and you've looked inside the software and the hardware, they're all kind of similar. And of course, the reality is that most humanoid robotics companies, there's 137 humanoid robotics companies in China. Most of those companies use similar batteries, similar actuators, similar sensors, similar subcontractors, and a lot of those humanoids are riffs off of very similar hardware and kind of similar software when you dig down deep enough. There are massive exceptions. A great example would be Elon's Optimus.
Sure.
They have a totally different perspective where they're building their own chips. And their view is, oh, we're going to own the cloud, the data, the models, the chips, the hardware, and we're going to be our own first customer for automotive manufacturing and all these other things. So that's a different perspective. But if you look at the 14 different Chinese humanoids that were at CES this year, once you've removed the plastic on the outside, there is a lot of similarity on the software and hardware.
Got it. So that was because one of my questions was that I'm going to just going back to Tesla and Optimus, or even like a company like Figure, right? So that's kind of focused on kind of complete vertical integration.
Uh-huh.
Is the conversation with you though? Is there like no interest there in kind of figuring out how to work together at all, because they're trying to completely vertically integrate and they're trying to try to keep this black box internally with what they're building, versus like, working with other software providers and other, I guess, middleware or intelligence layers?
Mhm. Well, I can't speak for Optimus or Figure, so I really don't know.
Mm-hmm.
I think for most companies, it tends to be beneficial in the medium and long term to engage with other parts of the technology stack and other companies. But there's definitely different business models, and Apple is a great example of awesome vertical integration from the hardware, which is made in China, to the software, which is designed and engineered in Cupertino. And they're obviously a great example of successful, exquisite vertical integration. So there's no right or wrong here. I'm just super pragmatic. And my goal is to make sure that the technology engages the largest number of people possible, and that humans have a fighting chance to understand what's going on inside the brain of highly capable humanoids. Some of the humanoids we have here in the lab can outrun you and seem to be getting faster and smarter pretty quickly. And so it's incredibly important to me, again, going back to this parent perspective, it's incredibly important to me that when we work on a technology like this, we do so in a way where lots of people can figure out what's going on, lots of people can contribute, and lots of people are able to like engage with the technology. Like, for example, one thing we're launching in about 2 weeks is a app store for humanoid. And this is mapping this concept of an app store from a phone to a humanoid. When you get a phone out of the box, for most people, they want other functionality. Maybe they want a weight loss app or a translation app or new social media, new ways of connecting. And of course, the App Store solves that problem. Apple and Google don't have to build all possible skills into their phone. And likewise, we don't want to be spending our time building all possible skills into humanoids. We would prefer hundreds of thousands of human developers in local communities in Detroit and New York and anywhere else to be using their skills to build those apps that can then make humanoids in your community more relevant to either your school district or your family. So when it comes to companies like Optimus and Figure, again, you have to be incredibly specific with what kind of problem you're trying to solve. And sometimes, vertical integration may be the way to go. And other times, maybe you have a different perspective. And we don't want this technology to be magic, parachuted from the sky into your living room.
I get it. I want to talk about the App Store concept for a second. So when you use the term App Store, should we think about it in the context of, as it kind of goes back to what you were saying before, there's thousands of models, over 1,000 models for robotics. Different things are great for different aspects.
Mm-hmm.
And so when we think about this App Store that you're building, are you kind of selecting certain robotic foundation models, packaging that up for is it a specific movement or a specific function? Like, how should we think about what each app does for robotics developers?
Typically, each app is a combination of different models. A great example would be, let's just say Saudi Arabia calls you and says, hey, we would like a humanoid to approach pilgrims. We would like the humanoid to speak a specific dialect of Arabic. And if and only if the pilgrim has symptoms of heat stroke, then give recommendation to seek medical attention and hand bottle of water to this pilgrim. That's an example of you might want to call it like a humanoid form factor nurse or receptionist type use case. And so what you need there is you need to choose what languages do you want to support. You need to decide what the rules are. What should this humanoid do or not do? You need to figure out what is the set of actions that you want to see the humanoid do.
Mm-hmm.
So that means you have to articulate choices about languages, prompts, rules, what functionality you want. And once you've made those decisions, we provide in our cloud models that we host that make it very convenient for you to snap together all the right models to, in aggregate, instantiate that set of functionality. And that involves you choosing models for like voice or spatial understanding or action generation or other rule sets. It involves you writing prompts. It may also involve you training your own models for like new movement policies. Imagine you want the robot not just to pick up and hand over a bottle of water, but maybe you want the robot to pick up a bottle of water and start juggling. In that case, you may need to train a movement policy for juggling, for example, or maybe some other combination of things. But when you snap it all together, you end up with a functionality that you can put on an app store, and then people who have suitable hardware can double click and download it to their robot.
And so this is like a whole, like when you imagine the amount of movements and functions, it's endless, right? So talk to us about kind of the initial focus or niche that you really want to start on this, because it's very fascinating to me because I've thought a lot about this. And sometimes you can kind of get paralysis when you think about how just infinite of opportunity and use cases there are. So is there an area you're focusing on?
Yeah. So I have great news for you.
Okay.
When you buy a Lego kit at the toy store, with 100 Legos, you can build a almost infinite number of objects. Trees and cars and people and homes and you name it. So our goal as a company is not to worry about what the imagination of humans can do when they get Lego blocks. Our goal is simply to provide a small number of useful Lego blocks that focus on things like remembering your name, not bumping into walls, being able to speak with low latency. And it's up to all the developers everywhere to figure out what problem they want to solve and then snap together the Lego blocks. So I don't wake up at 3 a.m. saying, oh, there's like 100 trillion different things I could be doing. But in terms of the use cases we're focusing on, like I totally agree. What we're doing as a company is to first approximation, forget hands completely. And so everything we focus on are high value, incredibly useful things that robots can do today without hands. And some roboticists, when they hear this, they will laugh. They will say, the defining feature of a humanoid is our hands. But then I tell them, look, there's a lot of people I know that only have one hand, or they are very successful people and they never use their hands to first approximation. Like right now, we're having this podcast. Our ability to have this conversation has nothing to do whatsoever with our manual hand dexterity. And for things like detecting medical emergencies, I don't need hands to do that. For teaching math, I don't need hands to do that. And that's the main way we're simplifying the problem right now. We are not focusing on chopping onions or anything like that. We're focusing on hundreds of different things that humans do that are incredibly useful and beneficial that do not involve mechanical hand dexterity.
Got it. So I want to talk a little bit about the training side of things, and kind of the long tail of training. And so it's pretty interesting. The more that I hear, when I heard you speak, I feel like you have a pretty interesting perspective, because you've probably looked at a lot of these thousand models for robotics. And based upon what you see generally, when you think about kind of data pipelines or robot training data pipelines, what's missing right now from that? Is there a common thing that you're seeing? Hey, like, okay, we have raw data, but like to create really effective pipelines, X needs to be built or Y needs to be built.
Yeah. Well, that's a whole like separate conversation. One pattern I've been seeing is that some big companies have workflows they would like to use humanoids to perform those tasks. But generally, those companies are very scared that you will parachute in there, you will record some assembly process, and you will turn that into a model, and you will take their crown jewels.
Yes.
And so then you end up in the situations where, let's just hypothetically imagine there's a car company. And then they say, oh, we would really like to automate this set of tasks. And then they say, oh, but the data can't leave our premises.
Yep.
And then you get into the situation where you're trying to navigate a company wanting to control a particular skill, workflow, proprietary assembly process, proprietary manufacturing process. And so there's an incredible amount of complexity at the legal side. Then all of a sudden you have like your lawyers negotiating agreements with their lawyers, and there's back and forth. And then, of course, they want the code to run on their computers, so their visual data or spatial data don't leave whatever company you're working with. And so that's something I've just seen recently play out a few times, where there's increased sensitivity about like a car manufacturer, a battery manufacturer, a chemical plant, or whoever the customer is, rightfully being concerned about the information about the process or workflow that they want to automate. And that directly goes against the notion of like a grand, unified, universal robotics model. How are you supposed to build such a thing if the companies you're working with want to quote unquote own that skill or optimize it for their factories? So this is one thing I'm seeing. The other thing I'm seeing is that all the data that we are able to access, like at YouTube or the internet or something like that, is already all in large language models and other models. To first approximation, that's all been quote unquote harvested, which is kind of an awkward term. Mm-hmm. And so more and more the focus is shifting to rare, secret,
Yep.
proprietary, not public data, highly specialized workflows. And then a major bottleneck there is simply, 3 months of negotiating with lawyers to somehow find a way of navigating this. The other thing are sensors, where for like the depth sensors we use, generally when we build our own models, we care about typical lighting conditions. We care about how high is the sensor off of the floor. We care about what the angle of the sensor is. We care about the kind of objects we want to detect in homes, for example. And so then when someone comes to us and say, hey, I have 100,000 hours of video with a webcam from the ceiling of 500,000 households, that has almost no utility.
Yeah.
Sure, it's unstructured data for homes, but it's not very useful for us. And so then we end up collecting our own data for the kind of robot form factor, camera, compute, other models that we care about mostly. So there's a lot of nuance in what data are useful, how they're useful, for whom are they useful, and so forth.
Yeah, it's interesting. Just even the past 6-9 months, there's been several kind of startup. There's many in the space, but several startups recently about kind of trying to tackle this kind of idea of long tail real world data.
Yeah,
Many of different approaches with wearables and different,
yeah.
constant data streaming from people wearing wearables, whatever it might be. But I think one of my questions on that was, when you think about taking raw data, and let's just say it has the variables that you're mentioning, it just seems like there's a missing middle layer to actually make that data usable or useful for you. But I don't know, just do you have a perspective on that? I don't know if you've used third service data providers at all that are collecting this data, or you're just doing it all in house?
Well, we've tried to use a few of them, but generally there was always at least one thing missing or wrong that would have been so complicated to fix that we're much better off adding sensors to robots and having them run around and collect the data we actually need. And there's really good news, though. Of course, there's a major push to reduce very dramatically the amount of data you need to evaluate, train, optimize particular models. So in the old days, maybe you needed like 1,000 terabytes of whatever, but what we're seeing more and more, and this makes total business sense, like no one wants to spend a decade collecting data. So more and more, we're finding it possible to get the functionality we want with much less data that would have been needed even 2 or 3 years ago. And there's synergy, of course, with that, with simulation environments like Isaac Sim.
Mm-hmm.
If the simulation environment is awesome and I can give it, the scenario I care about, and I get 100,000 runs in the simulator, I can get the model to pretty good performance. And then all I'm doing when I add real world data is I'm evaluating whether the thing I constructed entirely in silico also does well in the real world. So the really good news is that the amount of data that's required to build some of the models we care about is the amount of new real world data we need is shrinking quite quickly.
Great. I want to move over to hardware for a second. So I had a conversation a few months ago with Carl over at Physical Intelligence.
Uh-huh.
And, one of the things that he mentioned to me, because I kind of had this conversation, I was asking him is, when you look at kind of what's really missing to move this space forward. And he had a very specific answer around hardware. So
Uh-huh.
newly designed lower cost hardware, that, like I said, basically AI native software infused hardware essentially. And so one of the things that he was saying is they are actually getting into hardware themselves, and it was not part of the original plan. And so I just wanted to kind of ask you, are you dabbling around with hardware at all, just to speed up the process of your software development around on the intelligence layer, or are you completely staying away from hardware?
Well, if I moved my webcam around, you would see that we're drowning in hardware.
Okay.
And that's because, so I totally agree with that perspective from physical intelligence, started by one of my esteemed colleagues. So of course, physical intelligence is awesome.
Sure.
And we use some of their models actually because our stack just lives one layer above. We're
Yes.
really at the tactics decision making level. And then we need awesome software like from physical intelligence to convert those decisions into things like picking up the red apple and translating it. From a hardware perspective, the old model is that the sensors are pretty dumb and then you connect them through some massive pipe into your GPU, like an NVIDIA Thor. One thing we're generally finding useful is to do pre-processing very close to the sensor so that the data that come from the depth camera, for example, are not 20 gigabit per second raw data, but they're a higher level data product. And of course, your visual system right now, if you think about your eye, there's a lot of pre-processing that your eye does directly on the retina. For example, the way our brains find bright dots and lines, that processing is done directly inside your eye. So the data product coming from your eye to your primary visual cortex is not the raw pixel data from each of your rods and cones. It's already been compressed and enriched for information. And then what your primary visual cortex is doing is just yet another enrichment. So the way our brains are doing this is through a enrichment cascade where vast amounts of raw data are being filtered, compressed, reduced until a vanishingly small amount of information arrives in your like attention, whatever you want to call it. And that's been estimated to only be like 40 bits per second. Mm. And what we're finding useful for robot hardware is something similar to that, where the sensors at the edge are doing like filtering, calibration, various corrections, and giving us a reasonably high level summary of what they're observing, rather than us pushing raw data from all sensors into the GPU. So yeah, I think anyone trying to make humanoids awesome are going to be spending an incredible amount of time on sensors, where to do what compute, and what the right level of data compression and filtering is at the various intermediate levels of the hardware and software stack.
Got it. So are you building your own hardware, or you're just working with other hardware vendors at this point?
Well, before I answer that question, let me answer another question, which is, what's an awesome example of what we're just talking about?
Yes.
There's some nice IP that Tesla filed that had to do with making cameras more robust to being blinded by the sun. And the old way of doing that would have been to have the sensor be blinded by the sun, and then to have all the data flow into the GPU, and then software would have said, oh, camera currently blinded by sun. The much better way to do this is at the hardware level, augment the capability of the sensor, and then compute close to the sensor, and then again the data product arriving in the like central GPU is much more compact. In terms of us building hardware, I have a long exposure to hardware. In one of my previous lives as a physics professor at UC Berkeley, building instrumentation for soft condensed matter physics and trapping individual molecules, which involves lasers and cameras and actuators and feedback and power systems and all the other stuff, and writing computer code that does that. So I have an incredible amount of respect for hardware, and that's kind of why I'm scared of it. Mm-hmm. And so generally what we do as a company is we'll prototype things to the point where we kind of know what we want, and then we call up others who are hardcore hardware manufacturing people, and they will actually then turn it into a sensor or product. So we basically do rapid prototyping for hardware, mm-hmm. because that ties into our software, but then we have very little capability in like electronic sensor, CCD, actuator type hardware play.
Got it. And you mentioned obviously kind of the core let's just say the core user of the software right now, mostly being robotics developers that are working on humanoids, yep. in this case. But I did notice some information around kind of working, actively working with OEMs and enterprises. So can you just talk
Yeah.
about kind of what you're doing today in these early stages on the OEM and enterprise side?
Yeah. So for example, for the OEMs, generally what we'll do is we'll talk to an OEM, we'll get a few of their robots, and then we figure out what it takes to get the robot to support our software. And that's useful for developers because then we can say, you know what? The software now supports LimX. Now it supports Booster. Now it supports UbiTech. Now it supports Dobot. Now it supports AGIBot. Now it supports Unitree. And so that's just a service to developers. So they don't have to read esoteric documentation to figure
Sure.
out how to support some piece of hardware. In terms of B2B, what we're doing there is we're working with business customers that want to solve particular problems. So they'll, for example, say, you know what? We're in hospitals today, and what we do in a hospital is XYZ. We've noticed that it would be really interesting to have this type of task be on a moving platform that is able to approach people, perform a certain task, and then push the data into a hospital backend system like Cerner or like a electronic medical record system. And so they have a particular task they're trying to accomplish, for example, in a hospital, and they need that task to be performed reliably and in a compliant way with HIPAA, for example. And they also want the robot to be connected to their internal computer systems and their billing systems. So that then requires working with lots of different people to bring about that kind of functionality. And some of those examples will become public later this year.
Got it. So really, it's like that kind of turns more into integration work at that point. How do you integrate? Okay.
Precisely is a incredible. If you take a humanoid and you put it in a box and you ship it to a hospital and you say, congratulations,
Yeah.
here's your new humanoid, the hospital will look at this and derive precisely zero utility because that the humanoid needs to be turned into a useful solution to a specific problem a hospital cares about.
Sure.
And that involves the legal side, the compliance, the insurance, the charging, the maintenance, the training, the compliance, the like everything that goes on top of that.
Yeah, I heard a kind of a stat a few times, just some folks that kind of work in the space where it's like it's very often that the actual integration cost could be easily 5-6x the actual cost of the robot. And that's kind of like the dirty little secret of the cost of robotics.
Well, I mean, I wouldn't call it like a dirty little secret. It's something that, should be made explicit to potential customers.
Sure.
When you look at a typical hospital, there are dozens of things where all stakeholders are perfectly aligned to automate that.
Yes.
The nurses want it automated, the patients want it automated, the hospital chief medical officer wants it automated, the hospital chief financial officer wants it automated, the parents want it automated, and so all stakeholders are perfectly aligned. But even when that's true, there's still a lot of stuff that needs to happen. But it's kind of exciting for me because it's a great opportunity. And so everyone listening to this podcast, when you see humanoids in like newspapers, do not conclude that the ship has sailed. Don't think, oh, this is like way too late. This is all done. No, the physical humanoid that's able to perform tasks is a small step of many steps required to build an awesome business and have an awesome product. And so there's incredible opportunity for people everywhere in your city, your vertical, your skill set to think about that whole process of getting a piece of hardware and software to be an amazing solution for particular people, for particular need that people have around you.
It's interesting. It's a great point, because it's one of the questions I like to ask, especially folks more on the technical side, and for non-technical folks who are really interested in the space, and how do we move this ecosystem forward with who share similar values as you, Jan, as an example. Where do you see that the biggest need or opportunity where folks that might have a less non-technical background can really, I don't know, add value and potentially create interesting businesses in the space at this stage?
Well, I don't have a simple answer to that, unfortunately. There is a long overdue conversation about AI in general and robotics as well, as it relates to what the technology can do, what's coming down the pipeline, how this influences education, how your kids shall prepare for college, what this means for you, what the opportunities are. And it kind of breaks my heart that a lot of that information is hard to access. So if you're someone who's curious about this, but you don't happen to be working in a robotics startup in San Francisco, it may be incredibly difficult for you to understand or know what's going on and be able to think about what you can do with the technology. And one of the reasons I try to do lots of podcasts and like blog posts and other stuff is I want that information to be out there so a large number of people can engage with this and contribute and argue and provide feedback and so forth. So I'd encourage everyone to try to learn as much as possible what's happening. And if there's anything I can do personally, drop me a line, come visit. Our labs are open, drop
That's great.
by, we'll show you stuff. And it's really important for us that like normal developers can just show up and be and find utility in what we're doing.
That's great. So you spent pretty much your entire career in academia. I'm currently a professor at Stanford. Why start a company now?
Because this is the single most awesome moment in the history of technology. And the opportunity goes beyond like the Wright brothers discovering how to build, how to do powered flight. This is a situation where there's a technology where I can sit across from a humanoid, and the humanoid can win the Math Olympics. And I'm really sorry, but I can't. You might be, that's great, but I can't. And the humanoid sitting across from me can also beat me at chess, which is awesome. And it can also speak, 200 languages. And when the humanoid across from me learns a new skill, it can immediately share that skill with all other humanoids. And of course, as a teacher, when I'm teaching students, every human starts from nothing and spends 2 decades learning. And so when I look at this technology, the combination of hardware that can outrun humans, hardware that can run a marathon, like when's the last time I haven't run a marathon in 25 years, and then the ability to, once you've acquired a skill like juggling, to transmit that skill laterally to all other machines. That's a combination of amazing, and it should also make people pause and think, what do we want that technology to look like? And so if you asked me, like unquestionably, this has got to be the most amazing moment in technology ever, like without question.
Yeah, it's overwhelming in a way. Like, it's overwhelming when you see it and you just understand the enormity of it. And I think kind of is what you're saying, which is great, is you're remaining optimistic about it. And because I think it's just like there's a big dichotomy right now of optimism and pessimism. And if you remain optimistic about it and then become an active participant in shaping it, it's just such a cool time. It's such a cool time to like,
Well,
yeah.
so yeah, I'm fundamentally like optimistic, and I'm a long-term optimist. But concerned short term.
Sure.
Because whenever there's a new technology, if people have 300 years, imagine like the invention of the printing press.
Yeah.
And it took something like 100 years or 150 years for that technology to get to the point where most people had like a book in their home. So that's like what, 3 or 4 generations. So that's a situation where people in society and cities and towns and jobs, they can kind of adjust and adapt. But when you have a new technology that is maturing and developing explosively at explosive rates, you have to somehow reconcile that with like normal people.
Totally.
We don't completely retool ourselves overnight. It may take 5 or 10 years. And so I think the biggest challenge right now is simply navigating the next 10 years. But in the future, imagine everyone in the US could have affordable, exquisite quality healthcare at the level of Memorial Sloan Kettering or
Totally.
Harvard. That would be awesome. Imagine, imagine like old people who live at home alone would have convenient technology that keeps them healthy and safe and improves the frequency with which they connect to their kids that live 8,000 miles away. That'd be kind of awesome. Imagine making stuff, all the stuff you want in your kitchen and home. Imagine making it close to where you live. And imagine being able to participate in the process of making that stuff. And imagine the cost coming down. Why is it, for example, that if you're a teacher, you may have to spend a third of your annual income to buy a car? Is that a law of nature? No, it's not. What if cars were 20x less expensive? And so there is incredible opportunity, I think, in the long term to provide dramatic benefit to people. Another example is teaching. When I teach physics for pre-meds, I'm looking at sometimes 400 students and I'm looking up at them and it breaks my heart because for most of those students, I don't know their name because there's 400 of them. And this is like my experience at Berkeley, not at Stanford, by the way.
Okay.
And I know full well that there's 3 students in the class who know more about physics than I do. And then there's 200 students that really just don't care. And then there's another 100 students that really should not be in the class because they really should be taking a class in like intro calculus. And so as a teacher, I'm standing in front of those 400 kids and I know full well that the course content I'm delivering in that moment is some average that is not doing many students justice. So imagine you had a technology that was engaging with every single student and knew exactly what they know and don't know and is able to optimize their learning so they know as much as they possibly could. And so from my perspective as someone who's part of the medical school and as a parent and educator and so forth, I'm super optimistic long term. And what I'm concerned about, though, is short term because it takes time for people to wrap their heads around a new technology and retool themselves.
I think it's kind of this double whammy, right? You have what's going on technologically, which is going to be bumpy for the reasons you mentioned, but then it's at the same time that you have, we have a major, obviously we have a major debt problem that needs to be addressed, and kind of this whole reorientation back to like reindustrialization and getting away from kind of the agenda that we've been pushing for the past 30 years. Like that's just like a lot of change all at once. So I couldn't agree. I agree more. It's gonna be a little bit of a bumpy ride. All right. So let's, you ready for a little rapid fire and we'll wrap up?
Yes, sir.
All right. One myth about robotics you wish you would die.
That there is one robot that is equally capable to do every single task any one of us can potentially imagine.
Most overhyped idea in AI or robotics today.
Where do I start?
Biggest misunderstanding about embodied intelligence.
When you talk to 8 people about what that actually is, you get 12 answers. And I wish, at least as a field, we had consensus on what that even means.
One constraint people underestimate most.
As it relates to robotics,
Yes.
most robots today have been built in the lab and have never been exposed to a family, a workplace, a normal setting. When I started to program the humanoid I have at home, I was startled by how incompatible it was with a normal home. The cooling fans way too loud, the feet metal or plastic. So when the thing is walking around your home at 3 in the morning, the cooling fans are blaring and it's going bam, 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 bam on your wooden floor. You end up with a list of 20, 30, 40, 50 different things that need to be changed or optimized to make the technology really well suited for people's homes or workplaces.
Whose one person's work you follow deserves more attention?
Well, I love K-Scale and Ben from K-Scale, and the thing he was trying to do at K-Scale was completely awesome, which was to build a open source humanoid in the US.
Cool. Who else should I talk to here going direct based upon what you know about what we're doing?
Go talk to Ben again and ask him what his awesome next project is going to be.
Okay, I might take you up on that intro there. I'd love to talk to Ben. How can people reach you?
OpenMind.org, and my email is jan@openmind.org. And better yet, go to our GitHub and contribute, criticize, file issues, and tell us how to make things better.
Great. Well, listen, Jan, I really appreciate your time. Your spirit and approach, I think, to this space, and I think coming from academia and your focus on your intentional focus on how do we get as many people to be a part of this kind of huge wave in technology development, and it's going to have a profound impact on our lives that I appreciate. So thanks again.
Thank you, and I will be in Detroit soon.
I like it.
Go Michigan. Thank you. Bye.
See ya. Hey, my friends, Jordan here. First and foremost, a sincere thank you and appreciation for all of our early listeners, readers, and supporters at Going Direct. It's really what keeps me going to do this each and every week, because there's clearly a community of folks out there looking to build a going direct economy, which gets me super excited. Secondly, if you haven't subscribed, please do so. Our main channel and community is forming over on Substack. The link is in the show notes below. And we'll also be putting out our weekly conversations at YouTube, Spotify, and Apple Podcasts. I hope you all have a great day. And remember to go direct.